Okay.
I set up the electronic pad. Like
We can even try today. Okay, can you see the whiteboard?
Not yet. Yes.
Can you try to write on that?
Yeah.
Just to scribble and see whether it works.
I have to annotate on this. Like if I just write it to
You use the pen. The electronic pen is working as a mouse, right?
Yes. Yes.
When you move it on the whiteboard, the cursor tends to a pen or not?
No. No.
Okay, let me.
I think you have to allow me to write on
Hey,
the board.
Okay. Now give a try.
Yeah. I think that.
Yeah. Can you select the pin first? You see the
Yes.
pin
Yes.
at the
Yes.
bottom, right?
Yes.
Yeah.
Yes.
Okay. You can write on that. Okay.
Yes. I will get it.
Okay. So, so you got all the idea about the log functions, right?
Yes. Yes, sir.
Okay. Also, we did the change of the base. Something like let's say we have a log a to the base b. Okay.
Yes.
Change the base to x, something different. Okay. Now the current log function acting on the operand a is with respect to base b. Do you get that?
Yes. Yes.
Okay. So yeah, I think I remember we have done this, right?
Yes. Yes. Yes, sir.
Yeah. Okay. Can you try to do it on the whiteboard?
Yes. One. So you can take this one.
Yeah, I mean you can think loud also, or you start writing and see how you are writing and proceeding. I can just watch also.
Okay. So,
You can write and talk also, or you can just solve the problem. Change the base to x.
yeah. So, okay. First,
Just to keep the board as if like you have a writing pad and write.
yeah,
Think like
that's what I.
yeah, yeah. But it will take a time because you should not see the board. You should see
Yeah,
the
yeah, yeah.
screen, right? Yeah.
We can take it to be the variable. No, we can take it to be the variable x.
Okay. Stop here.
Okay.
First of all, log to the base b is a function acting on a, right?
Yes.
Okay. So we have been asked to
I
change
can't
the
use the
base to.
variable x. I can't use the variable x. I have to use the base.
Do you get that?
Yes.
So it's like we have to be clear with what is in the problem, and when we are assuming or letting some assumption on a variable or something like that, it should not conflict with the ones which are already provided in the problem.
Yes.
Okay, so this can be a y. That's
Yeah,
okay.
it can be a y.
Yeah, even you can start writing like let log a to the base b
Yes.
equals
Yes.
like that.
Yes.
That will tell us the let is totally a new assumption, and that should never conflict with the other variables or parameters in the problem. Okay, next step.
So here this will be if we change it to exponent, it will be b to the y to the power y will be equal to a.
Okay. Okay. Put a vertical line next to this so that you
Yeah,
can
yeah.
use the side of this one. Yeah. Yeah. Okay.
Taking time to write.
Yeah. It's okay. There will be a lag. So now we so if you see this b raised to the power of y equals a, actually if you swap the left to the right to the left, we will see that a equals b raised to the power of y. So actually the step you have done, the couple of steps you have done, assuming the given log function equals as a y and converting the log function into an exponential form, we have actually isolated the operand. Do you see that?
Yes.
Because the operand is a, actually that has been acted by a log function to the base b. So the given question is, can we change the base to x? So it's a simple problem. As long as we have the knowledge about explicitly what is our operand, then we can simply apply the log to the base x on that. So to do that, what you did, you let the given log function log a to the base b equals a new variable y, and converting this equation into an exponential form, you manage to get the operand in the original problem a simply equals b raised to the power of y. Then simply applying the log to the base x on both sides will give the problem solved. Get that?
Yes.
Okay.
Yeah.
Okay.
Okay, so I'll continue to that.
Yeah.
So log, and we can take this
log,
to be
log a to the base x. Keep a habit of, when you write the log, first write the as if you are talking. Like we will say log a to the base x, right?
Yeah.
So what I'm trying to say here is same thing. Log, right? Log first a, then to the base x. If you write like that, okay, mean completely when you complete writing, it will look like log a and x wherever it is. But we need to understand that always we say log the operand and the base. Okay, like that. Okay, log a. That is a, right? Oh,
yeah,
okay. Log b over y. Okay, equals.
Yes. Equals it will be log a the base x.
Yeah. So, if you have doubt about what you have written is right or wrong, check what you have done. Actually, you applied log to the base x on both the side of the equation you have. Right? So just hide in the new thing. Just hide this part. Just to think like you are hiding the log x on both sides. Then the remaining piece should look like exactly the previous equation.
Yes.
So that will tell us confidently what we are doing and what we have done is right and everything. That is always needed. And keep practicing that every problem you do. Then it will become a habit, and subconsciously we will be always looking after that. Okay. Okay. Next.
So we can take the y to the like it will be y log.
Yeah, it will be a multiplication factor with the y multiplication log b to the base x. Okay.
So then y will be equal to log a to the base x divided by log b to the base x.
Okay. Y is nothing but.
Y is nothing but log log a.
If you have written this as a log a to the base b.
Base b, yeah.
Because originally the y is not at all in the problem. We introduced that to represent this whole quantity. So eventually we have to say that log base b acting on the operand a can also be written as log a to the base x over log b to the base x. Okay, so
Yes.
you captured the whole idea, right?
Yes.
Okay, so okay, and there are lot of things we can do with the log function, and you need to get a good idea. Like for example, uh, take a simple parabola, like let's say y equal to x square or some ax square, right?
Yes.
Right, but if you try to draw a graph of this, then how the graph will look? Let's say this is the y value axis and this is the x. This parabola will look like
U.
up. If a is positive, then it will look like a normal U shape, right?
Yes.
Because for both positive and negative values of the x, once you are squared, the y will have only one value. You get the idea?
Yes.
So that's the reason, like when we draw a parabola, why we are having this kind of shape. Like if you take any one value of y that can go and meet the parabola line, actually it will have, like for example, if this is y1, there will be a positive and a negative value. So that is why this parabola looks like this. Do you get that?
Yes.
So for example, if it is a x square equals a y square, then it will look like a C. You see what I'm saying?
Yeah. Yes.
Yeah. Okay. And why I brought this into picture? Let's say we apply a log, even take a log 10 on both the side. So this will become log 10 acting on a x squared. A is multiplied with the x squared. So that multiplication can be split as a addition. You're okay with that, right?
Yes.
And the log base 10 acting on the x squared will be written as a 2 log x to the base 10. Okay, so this whole thing, after applying the log 10 on either side, has become a equation like this. Do you see that?
Yes.
Okay, now let's say if we call this capital Y as log y to the base 10 and capital X as log, is just a definition we are giving. Okay, log lowercase x to the base 10, then this thing can be written as a capital Y equals, this thing also we can call time being as a capital A. Okay, because it is a real number. Okay, so that will be a plus 2 capital X, right?
Yes.
So this can be also plotted as a graph. So I plot the graph here. Okay, so the graph between the capital Y and the capital X, it will look like a straight line with the y intercept value will be, when you have a straight line like y equals a plus 2x, the y intercept value will be, I'm asking about
a plus 2x, y intercept value will be 1.
Okay. Okay. Okay, let me take a small room here. Let's say you have a straight line that normally you learned it as a y equals mx plus c.
Yes.
Right?
Yes.
The first thing is, when we have full understanding about what is this y equals mx plus c and why this is actually representing a straight line, that will actually help us to do anything with the straight line or solve any problem related to the straight line. Okay.
Okay.
So here, okay, I might have already mentioned about this. Like here, x is our independent variable, right?
Yes.
So it can change on its own. It doesn't care about whether what is y or what is m or c. Doesn't matter. Good example is the time. Okay, time change on its own, right?
Yes.
then y is actually a dependent variable on x, on the independent variable. Okay, so that is why even we write normally the y as a y of x, exactly the same. Okay.
Yes.
So this is a variable, so it is not a single valued. It can have as many values as it likes. So when we have any value for the x independently that changed, and if we know a value, then that value can be substituted into the y function. That how to substitute? Let's say our x takes a value x1. You're okay with that?
Yes.
Then the y of x1, we write it as when x goes to x1 value, then that y value is actually written as a y1 equals, look at the equation for the y, wherever the x appear, the value of the x has to be substituted in there, right?
Yes.
So that will be m x1 plus c, right?
Yes.
Okay, so now in a straight line we need to understand it is nothing but two number line. One is for the x variable with its own unit, and one is for the y values with its own unit, right?
Yes.
Then we need to define any number line will have a reference point. So this could be our reference point, right? The intersecting point. So for
Yes.
the x-axis we give a value 0 as the reference, and also for the y number line, vertical number line, also we give a reference line as a reference point as a 0 value. So the coordinate points, x value for coming from the horizontal number line, the next one,
Yes.
the y coordinate for the vertical number line, both are 0 at that particular coordinate point. That is why we write it within the parenthesis 0, 0. Are you with me?
Yes.
Now if you see this straight line, there are other two quantities, the m and the c. We call them as parameters. Or even if you like, we can call them as a constant parameters. They won't change at all, because if you have already drawn a straight line like this, even though it may look like a variable, but they cannot vary like a x or y. They are fixed value for a given straight line. Do you understand that?
Yes.
Okay, so when you see a straight line here like this, so now we are looking after here, we have the variable y. Yeah, we know y is nothing but defined as the y of capital X, right?
Yes.
And x is our independent variable. Okay, independent variable. Good. Immediately whatever the coefficient for the independent variable in the y equation, this is what is called our gradient, that is our m value.
Okay.
Okay, and whatever added with that, this will be a constant, this will be our y-intercept value, that is our c value.
Okay.
Okay, why that is our c value? I will tell you why that is our c value. Simply y equals mx plus c. We are looking for, okay, the straight line can look like this. So we are looking for where the straight line intercept with the y-axis. That is why it is called a y-intercept. Do you get that? This
Okay.
point is called the y-intercept. Intercept, the literal meaning of the English word intercept is the line. The line is actually x mx plus c. You see that?
Yes.
So where the mx plus c intersect with the y-axis, that is our y-intercept value for the given equation, isn't it? Straight line equation.
Yes.
So what we know about this particular intersecting point, this intersecting point will happen only at the 0 value for the x. Do you get that?
Okay. Yes.
And it could be anything for the y. Why? Because it is the complete vertical number line that is passing through the x equal to 0 point. That is why the equation for the y-axis is also called x equals 0. You remember that, right?
Yes.
Okay, so when we want that straight line intersecting with the y-axis, what is our y-intercept value? All we need to do is, the x value is actually 0. Use that value in our equation. That is actually we are looking for y of 0. Right? That makes, purposely we are making the mx goes to 0. Then the c will be isolated. Do you get that?
Yes. Yeah.
So this whole thing will become a 0, and it says y value when x is equal to 0 is nothing but our c. This is the reason why we call the c as a y-intercept.
Okay.
Okay, so this has to be very clear. It's not because, I mean, we can think whatever we want with the given, like I wrote y equal to ax square, through which we got capital Y is capital A plus 2x. So this is actually a quadratic expression or equation, quadratic, which is actually graphically it will look like a parabola. In here also we need to understand what is the meaning of the y, what is the meaning of the x, and what is the parameter a means. You see that?
Yes.
It's very, very important. And in the graph where the a value will be, everything has to be understood very clearly. Okay?
Okay.
And when you come to the straight line, this is actually is called the linear equation or expression, and this is a straight line. Look like the graph is straight straight line, right?
Yes.
These are all like very, 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 very simple stuff, but the understanding has to be to a level that we should not even have a doubt about any of this. You get that?
Okay. Yes.
And even when we are seeing a straight line, you should see that the power here is a 1. The power here is a 1. As long as both the independent variable and dependent variable rise to the power, maximum power is a 1. No
Yes.
fractional or negative values or anything for that. Then we call that equation as a linear equation. You get that?
Okay. Yes, sir.
And this will be used in physics or chemistry or whatever the mathematical model for various examples. There will be plenty of models will fit into it. Like when you study the Newton's law, you will study V equals U plus AT.
Yes.
Study this, right? Then
Yes,
we
yes.
need to understand actually the velocity is actually a dependent function on the time.
Time. Yes.
It actually varies with the independent variable t. So that is why we write it as a u plus at. Again, here it is exactly same as y of x equals c plus mx.
Yes.
Okay, so instead of x we have the t, instead of m we have the a, instead of c we have the u. Same thing, instead of y we have the v. So when you see it as a graph, straight away when you draw the v versus t, then this intercept is actually our 0, u. You get that?
Yes, sir.
Okay, that has to be very clear. So, and also, I mean, the straight away, I mean, it doesn't matter, you write it as a y equal to mx plus c. And I gave another example, v equal to u plus at. And I might have given, something like, you remember we had, initially we deposited 50 rupees and every month we deposit 100 rupees, 100 rupees,
Yes.
100 rupees.
Yeah.
Yeah, that could also form a straight line. So the amount we saved against the number of months, we can simply say if this is the initial deposit D, then we can write the A, which will be changing every month. That will be starting with a 50 as our deposit as our y-intercept value plus the slope value. How much is the amount we are depositing for every month? To calculate that, we take a change in the month, how much change happening with the amount, that we divide one over the other. So we call that as the delta A by delta M. That is our gradient. You get that? So that will appear here. Delta A, the difference divided by delta M with respect to the month. Right?
Okay, yes.
Any questions or doubt?
No.
So here also you see again lot of basics involved with here on the, it is an equation, and in the equation left hand side is simply a one quantity. I mean, we already know that this is with the unit as a rupees. Right hand side is actually an addition. Do you see that? Addition can happen only, let's say you have a D is added with delta A by delta M multiplied by M. You can add a D with a full quantity because the whole thing is an addition. Do you see that?
Yes.
When that is allowed, when that is possible, only if the unit of this is same as the complete unit of this. Okay, if this is rupees, because why the deposit has to be rupees? Because the amount
also
is rupees. Yeah, this must also be rupees, right?
Yes.
Then only we can add a D with the delta A by delta M multiplied by M. But this has two different quantity. One is the delta A by delta M and another one is a M. Then we have to go finer refinement. The month, we know it is the month as the unit, right?
Yes.
Then we can question that what is the unit of delta A by delta M. That could be very easy. Like it's all, do you see that how they are all connected and how the understanding can be expanded, right? So we are saying that delta A by delta M multiplied by M, the whole thing is a rupees. The M alone is a month,
Yes.
right?
Yes.
So now we are questioning what is the delta A by delta M unit is what. If you want to know about that, always we can use the algebra for a handy one. All we are saying, if you multiply the unit of, that is X multiplied by the unit of the M is actually our month, right? This should be equal to rupees, because this is getting added with the D and equated to the A, because both these are rupees, right?
Yes.
The flow should be there, understanding should be there. You cannot just take a wild guess like when y equal to a plus 2x. What is y-intercept? Then you need to first of all look at what is available to us.
Yes.
Y-intercept itself is actually a straight line. First of all, we need to understand this is a straight line. In a straight line, there will be an independent variable and there will be a dependent variable and two other parameters. One is the y-intercept and another one is the gradient. That is what fixing how the straight line will look, right? In this given equation, we want to know only x, but x is multiplied with month, so divide month on both the side. That will tell us x unit is nothing but rupees per month.
Yes.
Right? So that is actually the rate of, at what rate the delta A by delta M is actually, we are asking at what rate we are saving the money. Okay, the rate of saving. Rate of savings. Right? So every month, let's say we deposit 100 rupees as a, so if the rate is constant, okay, then only let's say that this is actually our delta A by delta M. Are you with me?
Yes.
And the month, that could be 0 month, 1, 2, 3, 4, 5 like this. Then for all the month, our initial deposit will be always the starting minimum balance will be always 50 as an example. That is independent. Do you see that? This is always constant. That is why I write this as a constant parameter. So D is a fixed one, and also our gradient delta A by delta M is also fixed. As long as these two are fixed, then we can calculate the A is nothing but the initial deposit plus rate at which every month how much we deposit multiplied by the number of months will give you the value for the y. You get that?
Okay. Yes.
Okay. So here actually, even though we actually 0 month, even though the delta A by delta M has a value, but 0 multiplied with this, that is what is the first month saving, that is 0. So this will only be 50. You are with me? So this will be 150, this will be 250, this will be 350, right?
Yes.
450, like that. That is why there is a linear increase of this. That is why it is looking a straight line. Meaning, if you make a straight line, this point will be our 50, and you take any difference. Either you take a difference here, this delta M to the delta A, this will also go to a variation of 100. This also will give you a rupees 100 per month. Or you can take even a bigger one. It's also okay. We get that. This can be our delta A and delta M. Wherever you find, you take a interval from month 2. This could be from month 0 to month 10. So that will be that full difference, 10 minus 0. You have to take how much is this amount to this amount difference divided by the 10 months will give you the same rupees 100 per month. Do you get that?
Yes.
So the whole point is why it is linear, because the change happening is constant, right?
Yes.
So that is why I said if you put it in a graph and a straight line, take any point, like even here negative here also is okay. You take a point, then the same delta X, delta M, delta A, as long as this is our A and X, M. Okay, you take a point here, it's okay. Do you get that? So this will be our delta M, this will be our delta A. This thing also will be same as this ratio. Okay.
Yes.
Okay, but if you go to a parabola, you have drawn a parabola, right? So if you take a point here and a point here, try to find a change. Okay, let's say call that is our delta x1 and this is our delta y1. You understand what it means, right?
Yes.
But if you take a point here and a point here, delta x2, delta y2, in this case they won't be equal. Do you get that?
Yes.
What I mean is delta y1 divided by delta x1 will not be equal to
delta y1 y2 divided by x2.
Because it is not changing at the constant rate.
Yes.
You get this?
Yes.
So we need to understand that. That is why this is not a linear equation. This equation looks like something like a non-linear equation. It's a quadratic equation. There is a x square. The highest power of the independent variable or the dependent variable is not a 1. There is a square involved. That itself is saying there is a non-linear variation. Okay. And we are interested in how this vary, because linear variation we know that, right? You take any point, any 2 points anywhere on the graph, or even you find the difference even from the tabular column, or substitute the value and everything. They are the same at all the time, or all the independent variable value. The rate of change was constant. That is why it was called linear. All fine. But when you come to parabola, they are not constant, right?
Yes.
Then we are questioning how the delta y by delta x will vary. How it will vary?
dy by dx.
Yeah, that is dy by dx. But the question arises, right? Do you get that the validity of the question?
Yeah.
Because when we first took example like a velocity, time varying velocity, or a constant rate of monthly deposit. Or if you go and buy I gave you example, right? Let's say you are buying onions. If 1 kg is for example 50 rupees, then 2 kg will be 100 rupees, 3 kg will be 150 rupees. And if you buy some number of kgs of onions, add with a fixed, you buy a Kinder Surprise or something like that, that will be a fixed amount, right? It won't vary. Yes. Because of you buy different kgs of onion is nothing to do with our Kinder Surprise price. So the Kinder Surprise price, the price of the Kinder Surprise will be our y-intercept plus the amount of onion we want to buy, or the kg, right? Amount in kg multiplied with the rate. The rate will be, you see that rate, right? The rate. This will be our amount, or the price, the total price. Okay. This will also look like a straight line. Do you understand? Wherever this kind of, whenever the change, the rate, if this is going to be constant, then we are going to see a straight line. No problem at all. All clear. But when we come to the next family, which is something like a parabola, like ax squared, because of this power squared, this x is actually getting multiplied with itself. So in a straight line, so I put an example, y equal to mx plus c. In a straight line, you take any value of a x, go and meet the straight line, there will be only one value for the y. Yes. Right? Yeah. You take any y value, like any y value, call that as a y2, go and meet the straight line, then it will have only one x value. Yes, you can't have, for one particular value of the x or the y, you cannot have more than one values from the other coordinate. Okay? Yes. Yeah. That kind of variation is called the linear or straight line. Okay? Yeah. But in a parabola, we are saying the highest power is a 2, and depending on whether it is on the x or the y, that tells us how the parabola will look.
It will be an inverted u or a u.
If you take any particular value of x, okay, fine, you go and meet it and it will have only one value of the y. But if you take any one value of a y, this can be x1 and y1, let's say you take one value in the y, it can go meet the parabola in two different places.
Yes.
Okay, that according to this equation will tell us there is a minus x2 here and a plus x2 here. That is why for one value of the dependent variable, there are possibilities of two independent values for the independent variable. Okay.
Okay.
And when we start asking the deeper question, okay, then if the change happening in a parabola, if the change happening is not the same, right?
Yes.
Then that means what? The change, the delta y by delta x, this also becoming a function of x. Do you see that?
Yes.
In the straight line case, it was not at all function. The gradient is independent of the the independent variable or the dependent variable, right?
Yes.
Do you see how the development is happening from the straight line to a parabola?
Yeah, straight line to a curve. Yes.
Yeah, this will fit a straight line. Do you get that?
Yes. Yeah.
The variation happening will fit a straight line. So if you take a parabola like y equal to ax square, and you start finding the variation at a different point, okay, the different point variation, so there will be a delta y1 by delta x1, there will be a delta y2 by delta x2, there will be a delta, you can take as many points you like, right?
Yes. Yeah.
Delta x3 by, y3 by delta x3. If you take all these points, because you are taking this difference and take the midpoint of that, you will have you can call this as our x2 value, right? You can call this as our x3. We can call this as our x1, right? So you can have a graph between our delta y by delta x with respect to x. So the same thing, you have a x1 point, x2 point we took, and the x3 point. Then this will have a small value, and this will have another value here, and this will have a higher slope. When you connect them, this will fit a straight line.
Yes.
Get the idea?
Yes. Yeah.
Okay, so that is what we are developing one by one. Like, so if you go to the cubic one, okay, a cubic one.
Yeah.
So this can look like a y equal to some ax cubed. So for a particular value of a y, okay, the line can meet in 3 different places.
Yeah.
Okay, then even if you ask the question what will happen to the delta y by delta x, that will be varied. But how this will vary? This will vary in a square way.
Oh, okay.
Okay, then we go for the second difference, delta. Then even this is also a function of x. Then we question this is actually a x square variation, right?
Yeah.
You put a proportion. This is the proportionality. You know the symbol, right?
Yes.
Yes. Because there may be a constant sitting here. That's why I put it as a proportional. Yes. Then this is also. Then we look for the next order.
Delta x square. Yes.
That will actually vary as a linear.
Okay. Yes.
Okay. So from the main function, the first order difference rate will be a quadratic, and the second order difference rate will be a linear. Then the third order will become constant. Sorry.
Yeah.
Will become a constant. Okay. So this is also still function of x, but this is not a function of x anymore.
Okay.
You get that?
Yes.
So that is the reason when we had a y equal to mx plus c, it was very easy to calculate the m value. We said that it is simply for a particular range of the x difference, what is the change happening with the y? Fine. Because we said that y2 minus y1 and x2 minus x1. You know how to derive this also, right?
Yes.
You remember that, right?
Yes.
Because we can use 2 points like x1 comma y1 and x2 comma y2. These 2 points used on this equation will give simultaneous equation for the m and the c, right?
Yes. Yeah.
Then subtract each other, and then the c will be gone, and only the m has given you a. So this is okay, because you take any 2 points in the x and the corresponding difference in the y. This is the same wherever you go in the graph. So you can do like that. But when it becomes not a straight line, if it is a quadratic or cubic or something, this is going to vary. Do you see that?
Yes. Yes.
Then we need to go to so if you want to find the value, so you need to go to so many number of orders. So all these differences, when it becomes so much higher order, then all of them put together, because we are looking for some varying curve. If you want to find what will be the rate of change happening here or something like that, how the whole function is varying or something like that, then we need to make the delta x tending to 0, to the limit of delta x goes to 0. We can understand that as something like a microscope, because if I see it as a macroscope, the changes are too much. I don't know which order function, which power this will be. But if I go finer and finer to a level, even though we say delta x goes to 0, we don't completely go to 0. We go to only a point level, so that we find that small value of the x. So wherever I go to the next delta x, that variation in the y will be the same.
Okay. Yeah.
Okay, that is what we are calling that as the the derivative. So dy by dx, even though we define this as simply is the limit delta x goes to tending to 0, like we look for the difference, the function, let's say the function itself, that is the y of x plus delta x minus y of x, right, divided by the corresponding, this is actually the x plus delta x minus x. You see that?
Yes.
So when it is a straight line, this whole thing become a very easy, like y2 minus y1, this one. You get that?
Yeah.
But if it is not a straight line, then it will give you maybe if it is a parabola, then this whole thing will give you as that first derivative, the first order difference will look like a straight line.
Okay.
You connect that?
Yes.
So this is all we are, everything is connected, even starting from the numbers, counting, addition, subtraction, multiplication, division, and algebra, and the power, log, and everything. When you put it in a graph and everything, only in the case that, okay, if you have a line and you put it as a 1, 2, 3, 4, like this, and the negative numbers, -1, -2, -3, and if you look for what is the variation happening in the other quantity, if it is the same, like when it is 0, it is 0, right? When it is 1, it is a 1, and if it is a -1 also, it is a -1. There is no interesting thing, but it will look like a 45-degree line.
Yeah.
This will be actually, if this variable on the y-axis is x and the horizontal axis is x, vertical axis is y, we write this as a y equal to x.
Yeah.
Right? It is like every year I will complete 1 year of my age. Do you see that?
Yeah.
From the time we are born, if you count how many years has passed by, then our age will also be exactly the same. This graph is representing that.
Yes.
So it doesn't matter whether you look it at like, okay, from 2000 to 2001, what was my age difference, and divide by 1 is same as, you can take it as 2000 to 2010 divided by 10 years also is the same.
Yes. Yes.
Okay, so that is the whole understanding. So now when we go like, okay, even though we use a number line and start using all these things are all fine, but if it is not fitting y equal to x, if it is start looking like a y equal to mx plus c, then the two quantities here also is the same, but here in this case m is equal to 1 and c is equal to 0. It's a special case of this straight line, right?
Yes.
So when there are different values, like other examples I have told and everything, not the age, then we need to look for what is the value for the m and c, and how to look for it. Straight away when we wrote y equals capital A plus 2x, you should trigger your brain with the correct neuron to trigger everything, because this looks like, okay, the power of the x is 1, the power of the y is 1. Then this is nothing but a straight line which will look like y of capital X is actually equal to the y-intercept value constant A added with the constant rate of change. The 2 is a fixed value. It has nothing to do with our capital X or capital Y. So that it will be our gradient multiplied with the independent variable X. You understand this?
Yes. Yes.
Okay. So now why we went there, we took in the linear form, not in the linear form, in the normal form, or in the exponent form, y equal to a x square looks like a parabola, right? When we applied the log function, log to the base 10 on both the side, this converted into a straight line. Do you get that?
Yeah.
And note that whatever the order of the polynomial for the x, that will be the slope of the straight line.
Yeah.
When we have a cubic function ax cubed, this would have converted when you applied the log to the base 10. Capital Y will be still a straight line, but the slope will change to 3. Do you get that?
Yeah.
So this is a parabola. This is a cubic. Is a cubic. You know this word, right? It's a cubic function.
Cubic.
Yeah, it's a cubic function because of the rise to the power of 3. But once we applied the log, all the exponent index will become a multiplication factor, and they will start looking like a straight line. So this is a straight line looking like this. Okay, the slope is actually equal to 2. This will be a straight line. It will be more steep. This slope is actually equal to 3. Do you understand?
Yeah.
So why we do that? Let's say we measure something. We go to lab, or we do some, maybe a bridge and a structural architecture and everything, or even you do some communication, microwave communication, or whatever it is. Let's say we do an experiment, or we go to in reality we measure something, and when we get a data, then what we can do, we don't know with respect to the independent variable how the data is varying, isn't it?
Yes. Yeah.
So there are few ways to do the job. So when we know that the measured data is dependent on something, could be like our weather, right? Like the temperature of our place. So for every day it is varying. So let's say we have collected the temperature, average temperature for a given day for so many days, then it will form a data that will depend on the day, number of days, right?
Yes. Yeah.
So we can plot a graph, but that graph may look quite complicated, right?
Yes.
So what we could do, we can start finding the first order difference. Not going to the logarithm. I'm saying, let's say we do the first order difference. Okay, the first order difference also, it is not constant. That means definitely it is not a linear function, right?
Yes.
Then we go to the second order difference. If that is constant, then we know that it is varying as a parabola, a quadratic way. If that is not the case, we can go to the cubic or something like that. So that is one possibility. We can keep on doing differences. We go up to the order of the difference where we converge to a constant. Okay. Then we know that in what order that particular dependent function is vary with respect to the independent variable. Okay.
Okay.
That is one way. Other way is you draw a graph and try to find the value for the x and y and try to meet the curve and see at how many different points it is intersecting.
Yes.
You see what I'm saying?
Yeah.
If it is a parabola, then it will intercept at 2 different points, maximum.
Two different points. Yes.
Yeah. Then also we will get an idea. Or what we can do, you can do the calculus, right? The calculus is nothing but our the difference. That is called the finite difference. So finite difference method. So we do the first order, like the dy by dx can be calculated as a delta y by delta x. Okay. So this you can apply on a continuous function, but when it is a measured quantity, if it is all in the form of data, then we can do only this.
Yes. Yeah.
Okay. And also what we can do, let's say you have a data point, let's plot that. Okay, let's say you plot it and you find that and you make a curve fitting. Let's say you make that is called a curve fitting.
Okay.
Okay, curve fitting will fit a polynomial. Let's say the curve fitting fits a polynomial. This y to the x, the function itself y of x is actually proportional to up to the order of x power 7. Then we can fit a polynomial in x power 7. So the y as a function of x can be written as x power 7 will be the highest one. It will have its own coefficient a7. Do you understand this? This a6 x power 7.
Yeah.
All the lower order may or may not appear, but it is still possible. So we write it in a generic form. Do you get that?
Yes.
And it will go to a2 x square plus a1 x plus a0 x power 0 actually. This is the final count. This will be our y-intercept. Do you understand this?
Yes. Yeah.
Okay. So now once we made a curve fitting as a polynomial, then we are in business. For this we can apply straight away this. We don't need to make the finite difference or something. That is one way of application of the mathematics. Directly this become a continuous function, right?
Yes.
Even though we have data only between these 2 points, because of the curve fitting, even intermediate point can be calculated from this curve fitted polynomial function. Do you see that?
Yes. Yeah.
Or what we could do, if you do the log of that and take the data and do the log and plot it between the log to the log, then we will, let's make a straight line approximation of the log plot and calculate the slope of that. Then it will tell the slope is actually the delta y by delta x of the log. That will be our 7. Do you get that?
Yes. Okay.
So that is another way to do the measurement and analysis and everything. So all we are studying slowly one by one is, from the beginning we started with the numbers, and for all requirement and needed purpose we went to the addition, subtraction, multiplication, division, and up to the linear kind of thing it was all okay. But I mean, naturally or whatever we try to do as more artificial things or something, only straight line function was not enough. We need to go for the other functions and how to analyze and how to deal with all those functions. That is how everything is connected and what we are studying one by one. Okay.
Oh.
And also for every mathematical function there is an inverse or opposite function. That also we need to understand. So if you can do even an operation, if you do an addition operation, then there is an equivalent opposite one, which is a negative, subtraction.
Negative, subtraction.
Okay. So like that.
Yes.
So when you do differentiation, that is actually you are finding the difference rate. So when you do the addition of things put together, so when I said when you differentiate, you go to the microscopic level and see what is happening for the change. But if you come out, if you zoom out and see the whole picture, we will see exactly the whole function, right?
Yes.
That is what is called integration, the opposite of the differentiation.
Yes.
Okay. Yes. So try to always connect that, think over it, recall it, and don't leave it like, okay, I mean, suddenly when today you see we went and connected all this stuff, but you missed a point when I asked in a straight line capital Y equals capital A plus 2x. You could not immediately understand this as a straight line, and A is the y-intercept and M2 is gradient, and that gradient value is a constant. That means this will be a straight line. You see that?
Yes. Yes.
Okay. So let's say, I mean, I finished today like this. Let's say we write a function y equal to mx plus c. Right? This is how the scale. But let's say we write as y equals x plus c, but this is written as m of x.
Yes.
This is a straight line. This is a straight line. Now we make the e is varying with respect to x.
Yes.
Now we have to ask the question, m of x is how it is varying with respect to x.
Yeah.
Automatically the question arises. So that question leads to we do something. All the discussion we did in the recent past, we thought about how to find the difference and everything. Let's say the m of x itself is having ax plus b, for example.
Okay.
That follows a straight line. Then go to the main function, that is our y. That is actually basically defined like that. Substitute this guy here. That will be ax plus b into x plus c. This will work like a parabola. Do you get that?
Yeah.
Ax square plus bx
plus
c.
Plus c. Oh.
You see beautifully you get a quadratic equation.
Yes.
Right?
Yes.
So all are one and the same, but just becoming more requirement, as they are not as simple as like I can count a number of bananas with 1, 2, 3, 4. You cannot do the same thing with all the data in the in the nature or the measurement or whatever we do. They may vary on their own. Then we need appropriate mathematics and understanding to be developed for analysis and all the other purpose. Okay.
Yes.
So keep doing that. Whenever you do something, it's not simply the final answer or the right answer. It's the reason why it is so and how this is connected. Try to connect and bring it all of them, so that will become a habit for you, and it will be subconsciously, it will be working all this stuff like how I am explaining. All this should be working in your mind whenever you see something, how they are all connected. Even we can connect the trigonometry and other conic section. Everything will be connected because there are some geometrical representation is there, some algebraic representation is there, some data form representation is there, logarithmic form. So all of them are one way or the other for various requirement we need them. Okay. Any questions or doubt?
No doubt.
Okay. Next week I am not available, so we will meet week after next.
Okay.
Is it okay?
Okay.
Okay then. Okay. Bye.
Thank you, Uncle.
Yeah. Bye. Take care.